Let's explore Replica Set Maintenance, focusing on managing members, elections, and failover scenarios. This presentation will guide you through the essentials of maintaining a robust and reliable MongoDB replica set. A replica set is a group of MongoDB instances that maintain identical datasets, ensuring high availability and data redundancy. Key characteristics include having one primary node that accepts all write operations. Multiple secondary nodes replicate data from the primary. It provides automatic failover capability in case the primary becomes unavailable and offers read preference options, allowing you to direct read operations to specific members based on your needs. The diagram shows a basic replica set architecture with one primary and two secondary nodes replicating data. This setup ensures that your data remains accessible, even if one of the nodes fails. To add a member to a replica set, follow these steps. First, connect to the current primary member of the replica set. Then, use the rs.add method in the MongoDB shell, providing the hostname and port of the new member you wish to add. Finally, verify that the member has been successfully added by checking the replica set status. The code block shows examples of using rs.add. You can add a member with just the hostname, or with a configuration object that allows you to specify parameters like priority and votes. For example, rs.add, MongoDB.example.net 27017, adds a member with the default configuration. Alternatively, you can use a configuration object to set specific options, such as rs.add, host, MongoDB.example.net 27017, priority, 0.5, votes, 1. When removing members from a replica set, it is important to ensure that the remaining members can still form a majority to prevent data inconsistencies. There are two main methods to remove a member. The first is rs.remove, which removes a member by its hostname. The second is rs.reconfig, which allows for manual updating of the replica set configuration. The code block demonstrates both methods. To remove a member by hostname, use rs.remove, MongoDB.example.net 27017. To remove a member using rs.reconfig, you first retrieve the current configuration using rs.onf, then modify the members array using the splice method to remove the desired member. Finally, apply the changes using rs.reconfig, CFG. For example, the code shows how to remove the third member, index 2, from the configuration. A primary election occurs when the current primary member of a replica set becomes unavailable. Common triggers for elections include the primary becoming unavailable due to hardware failure, a network partition that isolates the primary, a replica set reconfiguration, or a manual step-down command. The election process involves several steps. First, the secondary members detect the primary failure. Eligible members then call for an election. Members cast votes based on their priority, with higher priority members having a greater influence. Finally, the candidate with a majority of votes becomes the new primary. Several configuration options influence the election process. Priority determines the preference of a member to become the primary. It ranges from 0 to 1,000, with a default of 1. Votes determine the number of votes a member has during an election. It can be 0 or 1, defaulting to 1. A hidden member is invisible to applications and cannot become a primary. The code block shows how to configure these options. To configure a member's priority, you first retrieve the current configuration using rs.onf, then modify the priority field for the desired member. Similarly, you can adjust the votes field. Finally, apply the changes using rs.reconfig, CFG. The rs.stepdown 60 command forces the current primary to step down, triggering an election. Failover is the automatic process where a secondary member takes over as the primary when the current primary becomes unavailable. Common scenarios that trigger failover include a primary crash due to hardware failure, a network split causing communication loss, and high load making the primary unresponsive. The failover process is handled automatically by MongoDB. First, the secondary members detect the failure through heartbeat monitoring. Next, an election is initiated, and a new primary is elected based on member priorities and votes. Finally, applications automatically reconnect to the new primary, ensuring minimal disruption. Effective monitoring and adherence to best practices are crucial for maintaining a healthy replica set. Key monitoring commands include rs.status, which checks the overall status of the replica set, rs.onf, which views the current configuration, and db@ismaster, which verifies if the current member is the primary. Important best practices include monitoring replication lag to ensure it remains within acceptable limits, maintaining an odd number of members to avoid split-brain scenarios, geographically distributing members across data centers for increased resilience, and regularly testing failover procedures to ensure they function as expected. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.